MA 104, Section 3.4. We are asked to find the vertex, find the axis or the axis of symmetry, and sketch the graph. This equation is already written in vertex form, so we know that the x-coordinate of the vertex is what we get when we take the opposite of what's written with the x, and the y-coordinate is the number that's written by itself outside, and these come from those properties of shifting. So the vertex will just be the point -3, -4. And again, that comes from the shifting properties that we looked at before. If I plot -3, -4, it is somewhere in the third quadrant. I know that because the a value, or the value that's in front of the parentheses, is positive, in this case there's nothing written, so it's understood to be a positive 1, that my parabola is going to open upward. I also know that the equation of the axis of symmetry is x equals -3, because the equation for the axis of symmetry will always be the vertical line that passes through the x-coordinate of the vertex. So the axis always has the equation x equals whatever the x-coordinate of the vertex is. So I know that my axis of symmetry would be the vertical line that passes through the vertex. Using all of this information, I can sketch a rough drawing of my parabola. This function is also written in vertex form already. The vertex can be found by taking the opposite of what's with the x and the number that is off by itself as it's written. So the opposite of -3/2 is +3/2, and then I have a -5, which translates to a vertex of +3/2, -5, which would be in quadrant 4 someplace. And again, it doesn't have to be perfect. The axis of symmetry is x equals whatever the x-coordinate of the vertex is, so x equals +3/2. That would be the vertical line that has all of the x-coordinates as +3/2. So it's the vertical line that passes through the vertex of the parabola. Because my leading number, or my leading coefficient, is negative, this is understood to be a -1, my parabola will open downward and look something like this. To find the equation of the parabola that matches up with this particular graph, I notice that the point that started out at the origin in the parent function has been shifted 2 units to the right. So I have a horizontal shift of 2 units to the right. I don't have a vertical shift at all, so there's nothing that's going to be added or subtracted onto the end. And my parabola opens upward, so a is going to be positive. So my function ends up being y equals, to account for the horizontal shift of 2 units to the right, that would be x minus 2 quantity squared, and then I don't have to add anything on to the end. If you're looking at your textbook, this translates to equation number 16, which is k of x equals the quantity x minus 2 squared. For number 20, the two shifts that have occurred, if I look at where the vertex of the sketch is versus the origin, which is where the vertex of the parent function is, this is a shift of 2 horizontal units, so 2 units to the right, and then 1 vertical unit, or 1 unit up. It's opening upward, so a is positive. Together, these shifts translate to x minus 2 quantity squared, because a horizontal shift of 2 units to the right translates to a -2. And then my vertical shift of 1 unit up translates to +1. If you are looking to match these up in your textbook, this matches up to number 13, which is f of x equals x minus 2 quantity squared plus 1. Number 21 gives us this graph. Again, it's opening upward, so we know that a is going to be positive. We know that that leading number is going to be positive. My vertex has been shifted from the origin to this coordinate by going 2 units to the right, so 2 horizontal units, and then 1, 2, 3 units down. So I have to account for a horizontal shift of a horizontal shift of 2 units to the right and 3 units down. The horizontal shift of 2 units to the right, again, is x minus 2, quantity squared, and then 3 units down would be minus 3. If I want to match this up with a function in my book, then that would be number 17, which is m of x equals x minus 2, quantity squared, minus 3. Next we have a parabola that is open downward, so I know that that leading coefficient is going to be negative. The parabola, or the vertex of the parabola rather, has been shifted 1 unit to the left, so a horizontal shift of 1 unit to the left, and then 1, 2, 3, 4 units up. So if I account for all of this together, I need the negative to show that it's opening downward. To account for the horizontal shift of 1 unit to the left, that would be an x plus 1 quantity squared. And then the vertical shift of 4 units up is plus 4. If I put all of these different elements together, they look like number 18, which is n of x equals the opposite of x plus 1, quantity squared, plus 4. This parabola is also opening downward, so I have to start with a negative to account for the opening downward. It has been shifted 1 unit to the left, so I have a horizontal shift of 1 unit to the left. It has not been vertically shifted at all. This gives me y equals the opposite to account for opening downward, x plus 1 quantity squared to account for the horizontal shift, and then no vertical shift. So this matches up with number 15, which is h of x equals the opposite of x plus 1 quantity squared. Finally, this parabola is also opening downward, so I need to lead with the negative. The vertex has been shifted 1 unit horizontally to the left and 2 units down. Putting all of these elements together gives me a function of y equals the opposite, and that negative again is because of the opening downward, the opposite of x plus 1 quantity squared to account for the horizontal shift, and then minus 2 to account for the vertical shift. And these elements together match up with number 14, which is g of x equals the opposite of x plus 1 quantity squared minus 2. In this particular problem, we're asked to complete the square to find the vertex form, to write the vertex and the axis of symmetry equation, and also to sketch the graph. In order to change this function into vertex form, I have to make sure that the quadratic coefficient is a positive 1. So I have to factor out this negative 1 from the first 2 terms. Doing so gives me h of x equals negative 1 times the quantity x squared plus 2x, and I still have the minus 3. If you were to check this, you could distribute this negative 1 back into these 2 terms, and you would still have what we started off with. So I just pulled out that negative 1 from the first 2 terms. To complete the square then, I have h of x equals negative 1 times the quantity x squared plus 2x. To decide what I need to add inside the parentheses, I take half of the linear coefficient, half of 2 is 1, and then I square that. 1 squared is 1. So I will add a plus 1 inside the parentheses. I still have the minus 3, and then I have to consider what I need to take off of the end so that I can balance everything out. I put a plus 1 inside the parentheses, but everything inside the parentheses actually gets multiplied by a negative 1. So when I put this plus 1 in here, and I times it by this minus 1 out here, really I've introduced a minus 1 into this problem. To counterbalance that then, I would have to add 1 onto the end. So the opposite of minusing 1 or introducing a negative 1 is to add 1 onto the end. This equation is now ready to be written in vertex form. I have h of x equals negative 1 times the quantity. X squared plus 2x plus 1 factors into x plus 1, quantity squared, and then minus 3 plus 1 is minus 2. This is vertex form. So this is my original equation written in vertex form. The vertex is whatever I get when I take the opposite of what's with the x and then the constant as it's written. So this gives me a vertex of negative 1, negative 2. And then my axis of symmetry equation is always x equals whatever the x coordinate of the vertex is. So in this case it's x equals negative 1. To put all of these elements together to sketch my graph, I know that the vertex is negative 1, negative 2, so somewhere in quadrant 3. I know because of the negative 1 outside that it's going to open downward. So when I sketch that, I get a parabola that looks something like this. Very, very rough to sketch. I am asked to perform the same operations for f of x. I'm asked to write the equation in vertex form first. And again, that involves factoring out the coefficient of the quadratic term. So in this case, factoring out the positive 2. This leaves me with f of x equals 2, and I'm factoring out from the first two terms. So that will be x squared minus 12x, and I still have the plus 90. So in other words, if I were to factor that 2 back inside the parentheses, I would get what I started with. I just pulled out that 2 from the first two terms so that I had an x squared by itself. This then leaves me with f of x equals 2 times the quantity, x squared minus 12x. To figure out what number to complete the square, I take half of the 12, which is 6, and square that, which is 36. So I'll be adding 36 inside those parentheses. I still have the plus 90, and then to figure out what I need to be able to balance the equation, I added a 36, but because everything inside the parentheses is being multiplied by 2, what I really introduced to this was a 36 times 2, which is 72. To balance that off, I have to minus the 72 off of the end. So when I added the 36, that got times by 2. So 2 times 36 is 72. I added 72 into this equation. To balance that, I take the 72 away. To write this in vertex form then, I have f of x equals 2 times the quantity, x squared minus 12x plus 36, factors into x minus 6, quantity squared. Plus 90 minus 72 is plus 18. My vertex then, the x coordinate is the opposite of what's with the x, so the opposite of a minus 6 is plus 6, and then the plus 18 comes down directly, so my vertex is 6, 18. My axis of symmetry, the equation is just x equals whatever the x coordinate of the vertex is, so x equals 6. My vertex is at 618, which is up here somewhere in quadrant 1. Because my leading coefficient or my leading number is positive, that means that the parabola opens upward. And again, this is a very rough sketch of the graph of this particular equation.